Let's look at a similar problem. Now Mr. Tall is still 6 buttons. Mr. Short is still 4 buttons, but is 8 paper clips tall. Now what would you do to find how many paper clips Mr. Tall is?
I'm going to try to see if groups of 2 paper clips match up to 1 button. So 2 paper clips do match up for 1 button.
Can you use that information to figure out how many paper clips Mr. Tall is?
Yes, since Mr. Tall is 6 buttons and 2 paper clips fit for each button, then I can do 6 times 2 to find the paper clips for Mr. Tall, which is 12.
Okay, so what would you do if Mr. Tall was 8 buttons tall?
Is Mr. Short still 4 buttons and 8 paper clips?
Yes. That has not changed.
So 2 paper clips is still equal to 1 button. So Mr. Tall would be 8 times 2, which is 16.
What if Mr. Short was now twice as tall? How many buttons and paper clips would he be?
So 8 buttons and 16 paper clips.
Yes. Could you find how many buttons tall Mr. Short would be if he was 1½ times taller?
What do you mean 1½ ?
He was originally 4 buttons. If he is now 1½ times taller, how many buttons would that be?
4 times 1 is 4. Half of 4 is 2. So that makes 6.
So how many paper clips would Mr. Short be if he was 6 buttons tall, and we're using the same relationship between buttons and paper clips?
So 2 paper clips is still equal to 1 button?
Yes. That is still the same.
So 6 times 2 is 12. He'd be 12 paper clips tall.
That's right. So do you see some sort of relationship between paper clips and buttons for Mr. Short?
Sure, it's 2 paper clips to each button.
So, is there a proportion between buttons and paper clips?
Yes, because we'll always have 2 paper clips for each button.
And can we use that same proportion for Mr. Tall?
Yes, because the size of the buttons and paper clips are the same for both Mr. Short and Mr. Tall.
That's right. So using the relationship between buttons and paper clips that we discovered for Mr. Short, can we always find the number of paper clips for Mr. Tall?
I think so, because the proportion remains the same, right?
That's right. The proportion between buttons and paper clips is constant and doesn't change, but the number of buttons can change.
Oh, I think I get it now. The 2-to-1 relationship of paper clips to buttons is the same for Mr. Short and Mr. Tall. It's just that Mr. Tall has more buttons to start with, so he will have more paper clips.
That's terrific. You seem to understand that there is a proportionality between buttons and paper clips, and that you can take the relationship between these 2 items from one application and apply it to a second application within the same problem. In our case, the 2 items were buttons and paper clips, and the 2 applications were the height of Mr. Short and Mr. Tall.